Okay, this video is about polynomials and linear factors. This is section 6.2 in your book. I'm going to start off by talking about how to solve problems like this. If you have a polynomial expression, but it's written out in terms of its linear factors. So what do I mean by linear factors? Well, let's take the number 6 as an example. 6 has factors, 2 and 3. So 2 is a factor of 6, 3 is a factor of 6. These are called prime factors. It's the smallest version of a factor that we can get for 6. When you're dealing with polynomial expressions, let's do x squared plus 4x minus 12. You can write out the factors of this. X plus 6x minus 2. These are the two factors. These are called linear factors. This, x plus 6, if I was to graph it, this would be a line. Okay, so that's called a linear factor. It has a linear term. So polynomials can be written in terms of their linear factors. That's what we have right here. This polynomial is written out in terms of multiplication between its linear factors. X plus 1 is a linear factor, x plus 2, and x plus 3. So what we're going to do is we're going to write a polynomial in standard form from these two. And the way you do that is similar to if we just had this problem. We would FOIL this out. And so let's go ahead and do that. Let's multiply this stuff. My math teacher in high school called this the Charlie Brown because he said that that looked like Charlie Brown. So you do x times x, and that gives you x squared. You do 1 times 2, and that gives you plus 2. You do 1 times x, and that gives you x, and you do x times 2, and that gives you 2x. So now let's simplify this by adding like terms. These two are the only two like terms, but we're also going to write it in terms of highest degree to lowest degree. So that would be x squared plus, now if we add these two together, you get 3x plus 2. So I wrote that, rearranged it. This is what x plus 1 times x plus 2 is. Alright, now let's go ahead and take this and move it up over here. Yeah, we'll move it over here. Let's make it smaller too. Alright, so now we have those two. That's the first two multiplied together. Now we need to multiply it by x plus 3. So the way I would suggest doing this is multiply x times all three terms. 1, 2, 3. X times x squared gives you x cubed. X times 3x gives you 3x squared. X times 2 gives you 2x. And now let's multiply 3 times all three terms. 3 times x squared gives you 3x squared. And actually, you know what? I'm going to write it underneath the other ones. 3 times x squared gives you 3x squared. 3 times 3x gives you 9x, and 3 times 2 gives you 6. I like to write it this way when I multiply out like that so that I just already have the like terms next to each other. It makes adding easier. So I've got x cubed plus 6x squared plus 11x plus 6. This is the polynomial expression in standard form. Standard form has the highest degree first, and then in descending order. So highest degree, second highest degree, third highest degree, lowest degree. So that's how you write an expression in standard form. If you need extra help, I'm going to do this one in the extra help video. Okay, now let's go the opposite direction. Let's go from standard form and let's write in factored form. So when you factor a polynomial, it's similar to when you factor a quadratic. The first thing you do is you look to see if they have anything in common. Is there a greatest common factor between these three terms? In this case there is. They all share an x in common, and they all share a 2 in common. So I can factor out 2x, and from here I'd be left with x squared. Here I'd be left with 5x, and this last term would leave me with just 6. So if I factor out the 2x, this is what I have. And now the stuff inside of parentheses can factor also. What multiplies together to give you 6 and adds together to give you 5? 3 and 2. Positive 3 and positive 2. So that means I could rewrite this as x plus 3 times x plus 2. So these are the linear factors of that polynomial in standard form, and this is factored form for the polynomial in standard form. If you need to see another example, I'll do this one in the extra help video. Let's talk about some key features of this graph. Okay, so this, first of all, is a cubic function. It's something that's similar to that. It's in that form. This is the parent function for that shape of graph. So here are some key values right there, right here, and right here. This line, the y-axis, the x-axis, goes through the point y equals 0. So if I was to say what value is this, it's 0 for y. It's not labeled. But the line y equals 0, it goes through these 3 points. Those are called zeros. Zeros. Like that. Not like this. The E, it makes this a verb, and that's like he zeroes in on the answer, but zeros means the values for x that you would plug in that make this function equal to 0. So this blue function crosses 0 when x is 15, 0, and negative 10. So negative 10, 0, and 15 are the zeros of this function. That's one key value. Another thing is the y-intercept. Where does this cross the y-axis? So the zeros is where it crosses the x-axis. The y-intercept is here in this case at the origin. The y-intercept is at the point 0, 0. Two other key factors that we'll talk about are these values. Okay, this is a really big value. It's not the maximum value of the graph. This graph keeps on going over here forever. So if it keeps on going, it's going to be higher than this point at some thing. So this isn't the maximum, but it is a maximum. We call it the relative maximum. Relative. This is the relative maximum, and this is the relative minimum. Because similarly, over here, this just keeps going down. And so there is a minimum value that's lower than this, but it's the relative minimum. So the things you need to be able to recognize from a graph like this are the zeros, the y-intercept, and the relative maximum or minimum. So on this one, I want you to pause it and see if you can identify those things, and then hit play on the video. The zeros are at negative 3, negative 1, and 2. The y-intercept is down here at negative 6, y equals negative 6, or the point 0, negative 6 is fine. The relative maximum and minimum are here and here, those points. So the relative maximum in terms of y, it looks like is about 4, and negative 8 is the relative minimum. So this is 4, this is negative 8. And then the x value, this is about 0.8, and this looks like it's about 2.2. So you could say the relative max is at the point 2.2, 4. The relative min is at the point 0.8, negative 8. Okay, so what we're going to do is we're going to look at a polynomial equation, what's written in factored form, and see what we can tell from this. Well, the zeros of a graph, we just talked about this, are the places where it crosses this line, y equals 0. So if the y value was 0, if this was 0, what would the x values be that would make this graph equal to 0? Let's look and see. So this wasn't the actual graph of that function, that was just a sketch. So if that was 0, then what we learned before, one of these factors has to be 0. The only way you can have 3 things that are multiplied together equaling 0 is if one of them is 0. So that means x minus 2 would make this whole function equal to 0 if x minus 2 was equal to 0, or if x plus 1 was equal to 0, or if x plus 3 was equal to 0. If we solve each of these for x, if x equals 2, then this factor is 0, so the whole thing is 0. If x equals negative 1, this factor is 0, so the entire function is 0. And if x equals negative 3, then this factor would be 0, and so the entire function would be 0. So the zeros of the function y equals x minus 2 times x plus 1 times x plus 3 are these values here, 2, negative 1, and negative 3. So if I was to actually draw a graph of this, Actually, I think that is the graph that I had here. Yep, -3, -1, +2. This is what that graph looks like, and this is the equation for the graph. Okay, so now I'm going to look at this problem. If I was going to find all of the zeros of this function, what would I need to do? Well, this is kind of combining the second example that we did with the previous example. You want to write this in factored form first, and then you could tell what the zeros would be. So factored form, first things first, let's look for a greatest common factor. Is there anything that all of these terms share in common? The answer is x squared. X squared is the greatest common factor of those three terms. From the first term, you'd be left with x squared. From the second term, you'd be left with 6x. And from the last term, you'd be left with 8. Okay, now we can factor this. What multiplies together to give you 8 and adds together to give you 6? 4 times 2. +4 and +2. So this is factored form for this polynomial equation. So the zeros would be, what is this when f of x is equal to 0? Well, f of x will be equal to 0 when x squared equals 0, or when x plus 4 equals 0, or when x plus 2 equals 0. X squared equals 0 when x equals 0. X plus 4 equals 0 when x is -4, and x plus 2 equals 0 when x is -2. So these are the zeros of the function. Now it's important to notice that because you have this x squared over here, I could write that as x times x. X times x. Well, x equals 0 when x is 0. So all this means is that 0, x equals 0, shows up twice. And we call that a multiplicity of 0. Multiplicity. If you have a 0 that shows up more than one time, it has a multiplicity. So this, for example, x plus 3 squared times x minus 1 to the 4th. X equals -3 is the 0, and x equals 1 is a 0. This 0 has a multiplicity of 2, and this 0 has a multiplicity of 4. It means it shows up 4 times. I could write the zeros are x equals -3, -3, 1, 1, 1, and 1. And that would be all of the zeros. But instead of repeating myself, you can just say multiplicity. That's what that term means. Okay, so now we're going to go into reverse mode, and we're going to write a polynomial function in, that's what this word is, in standard form with zeros at -2, 3, and 3. So here you see the multiplicity. I could have said -2 and 3 with a multiplicity of 2, or you can just repeat the zeros. This is really important that you repeat the zeros. If I didn't, if I just said it has zeros at -2 and 3, I'll get a very different answer. So let's go in reverse. If I have a 0 at x equals -2, what that means is, if I were to add 2 to both sides, x plus 2 equals 0, this x plus 2 is one of my factors. I'm going to switch over to white so that you can see it easier. So x plus 2 is the factor that you get from the 0, -2. So we're going to write y equals x plus 2. That's one of them. And then x minus 3 is the other one, because if x equals 3, then x minus 3 equals 0. So this is your linear factor. But then it shows up twice. X minus 3 shows up twice. So this here is our polynomial in factored form, and we need to write it in standard form. So we need to multiply this out. So I'm going to multiply out x minus 3 times x minus 3 times x plus 2. Notice I just changed the order. The order doesn't matter. I'm going to get the same thing either way. So let's start with these first two, and let's FOIL. X times x is x squared. -3 times x is -3x. X times -3 is -3x. And -3 times -3 is +9. So I can write that as x squared minus 6x plus 9. And then multiply this times x plus 2. I'm going to erase this to give me some space to do that. Let's go ahead and move this up. And let's FOIL it. Let's do x times all three. X times x squared is x cubed. x times negative 6x is negative 6x squared, and x times 9 is 9x. 2 times x squared gives me a positive 2x squared. 2 times negative 6 gives me negative 12x, and 2 times 9 gives me a positive 18. So this is x cubed minus 4x squared, minus 3x plus 18. And that equals y. This is a polynomial function in standard form with zeros at negative 2, 3, and 3. Okay, now at the beginning I said this is really different than negative 2 and 3. If I didn't tell you that there were 2 zeros at 3, this is what I would have. X plus 2 times x minus 3 instead of that x minus 3 twice, and that would give me x squared minus x minus 6. Very different answer than what we actually should have got. So it's really important that you state the multiplicity and that you treat each of these zeros as separate zeros even if it is the same number. And that's it.